for joining today's session. Yeah, so thank you for joining today's session. So we'll just jump in and feel free to ask any question in the comment while we discuss today's topic. So I'll just go ahead and share my screen. Okay, you can see my screen, right?
Yes.
Awesome. So let me just go to the first slide. Okay, so on today's workshop, we're trying to understand how Scroll works and the whole context of zkEVM. All right. So first off, we need to understand why do we need platforms like Scroll? Obviously, it's to scale Ethereum using zk proofs. There are so many sort of like scaling solutions. We have optimistic uh optimistic and the ones that use zero knowledge, and Scroll is one of them. So we will go what it means but when we say zkEVMs, how Scroll works, and of course we finish by deploying a simple smart contract on Scroll, and you'll be able to build your applications afterwards. Yep. So, of course, need to understand the whole problem with Ethereum and why we say we need to scale it. Obviously, like executing every transaction on Elon is super expensive and slow. So, what do we do to speed up that process? We get prolapse like Scroll, and Scroll, as we've said, uses L2s like Scroll. Okay, and let me know if I'm going too fast or if anyone. Okay. Okay, can you hear me? Sort of like got disconnected for a second.
Yes, we can.
Oh, awesome. So I was on the Ethereum's throughput limits, and the solution is okay. Yeah, the solution is okay. You need to move there. Okay. Yeah, I went too far. Yeah, the solution is rollups, like a Scroll. As we said, like it's like moving computation off chain, meaning off the mainnet like Ethereum. So computations are done off the mainnet, and the only thing that's being posted to the mainnet is the proof. We have two types of rollups, of course, optimistic rollups and zk rollups. zk rollups use this mathematical proofs, like cryptographic proofs. They just post cryptographic proofs to Elon's like Ethereum. So what is zkEVM? Say it like someone described it as like an upgraded Ethereum computer that uses cryptographic proofs. So like the execution environment is the same as Ethereum's, but now it uses zero knowledge. It uses a zero knowledge system. So same bytecode as Ethereum and producing cryptographic proofs. All right. So the results being that Ethereum doesn't need to like rerun all the transactions. It only verifies the proof that gets posted to it. All right. So see the Ethereum execution environment, the same execution environment as Ethereum, but it's not on Ethereum, it's on L2s like Scroll. All right. Yeah. So what do we mean when we say equivalent? That means like it's like implementing the same EVM bytecode, like the bytecode levels. They're like different ZK EVMs, some trying to be like the same execution environment as Ethereum, some sort of like tweaking the bytecode a bit, but like tweaking the bytecode a bit. So with Scroll, we say that it's EVM equivalent, meaning like it's sort of like the same bytecode level as EVM itself. Meaning like developers basically don't need to use different development tools. It's like the same Solidity code they would that would get executed on Ethereum itself can be executed on Scroll. Basically, nothing's changing much when it comes to execution environment. All right. So Scroll's execution layer sort of like almost the same as Ethereum's. Okay, so that's what we mean by EVM equivalent. Almost the same as the execution environment that's on Ethereum itself. Okay, so on the next slide is how Scroll works. Of course, like it has, we say Scroll is modular, meaning it's like different layers, and every layer has like a different functionality. Okay, we have the settlement layer, which is Ethereum itself. It provides like data availability and proving verification and bridging. We'll talk more about bridging later. And we have the sequencer layer on Scroll. We know what sequencers do, right? They execute transactions and batch these transactions into like blocks and like batches. And after they have been batched or in a block, we can generate a proof. So we have the prover layer, or as Scroll calls it, the roller network. This generates the cryptographic proofs, and those are the ones that get posted to L1 for finality. Okay. Can someone admit? I can see two people in the waiting room. All right. And feel free to distract me if anyone has a question or got lost. Okay, so we've seen these layers: settlement layer, sequencer layer, and the prover layer. So settlement layer, it's Ethereum itself, obviously guaranteeing security and finality. Finality is when we post that cryptographic proof, and like the final finality happens on L1s. Okay, so we have functions like DA, meaning like data availability. So Scroll posts the compressed transaction data and state root to Ethereum. Like it's a lot, but like yeah. And ensuring that all transaction history can always be reconstructed to L1. That means that's what we mean by like DA, like the data availability aspect of it. And like with our proof verification on L1, we have like the the verifier contract on Ethereum. Like it's also called the rollup contract. So it receives the validity proof from Scroll and checks them using zkSNARK's verification logic. So it's a lot when you hear these proofs. Scroll uses zkSNARKs, meaning there's zkSNARKs and zkSTARKs. Scroll uses zkSTARKs, meaning the proof is small, like the size of this proof is succinct. It's small enough, and yeah, it gets posted to L1 for verification. So, and the bridging and messaging. Basically, I would say this is the same unless uh, proven otherwise, because we're talking about like the communication between L1 and L2. So if we transfer assets from L1, yeah, say 20 tokens or NFTs from L1s to Scroll, I would say messaging, communication between the two, or like, yeah.
I'm sorry to interrupt you. Really sorry.
Okay.
But can you please make me co-host so I can allow people in?
Maybe mod 2, I'm unable to right now.
Okay, let me talk to my sister. Go on.
Okay. All right. So yeah, settlement layer being Ethereum itself, providing data availability and the proof verification and bridging and messaging. Yeah. So the second layer being the most interesting bit, I would say, is where's this? It's the sequencing layer. It's the scroll execution environment. So it receives transactions, orders them, executes them, and batches them, uh, to be proven and verified on L1s like Ethereum. So when we talk of sequencing layer, we have like two components. There is the execution node with the scroll and the rollup node. All right. So with rollup node, basically it scrolls modified version of Go Ethereum. If you know about like EVM execution environment. So scrolls modified version of Go Ethereum, and it's responsible for maintaining the L2 blockchain state. So on this execution environment, so executing transactions with the same EVM logic as Ethereum, as we've said, Scroll is EVM equivalent. So executing transactions with the same EVM logic as Ethereum itself. So making Scroll's bytecode equivalent to Ethereum. Also on execution node, so collecting transactions from users and loan deposits, validating them, executing them, and maintaining scrolls state, meaning like balances, storage, contracts, and all that. It also like where it exposes the same RPC interfaces as Ethereum, and yeah. So executing transactions, same EVM logic, and yeah, making scroll bytecode equivalent to Ethereum. So on the same sequencing layer, the second component being the rollup node. So here is where we see now batches, like batched transactions, and coordinating with the prover layer to attach the validity proof to those batches, and submitting the proof to now Ethereum rollup contract for verification and finality. So together, obviously, this makes up like the sequencer on Scroll. So sequencer, ordering and batching transaction, and like this executor on this layer running transaction under zkEVM and producing the result state. All right. So the next component is the proving layer. Of course, we need to be able to produce these cryptographic proofs to these batched transactions. All right. So it handles the cryptographic proof generation and converting the transaction batches to zk-SNARKs proofs. So as we said, you know what zk-SNARK? It's like two types of proofs. We have zk-SNARKs and zk-STARKs. zk-SNARKs is like succinct, non-interactive argument of knowledge. So the verifier and the prover don't need to go back and forth to produce a proof. And it's succinct, meaning it's a small proof. Okay, now we have a proof, and we go back to like the settlement layer, where now that proof is being verified. All right, so I hope you get this right. We have settlement layer, which is Ethereum itself. So responsible for data availability, proof verification, and messaging or like bridging. And then we have the sequencer layer that has that has execution node and rollup node. So receiving transaction and like batching them together. And now after that, we can generate proofs, and that proof is posted to Elon. And the type of proof that Scroll uses is zkSNAK proofs. All right. So going through the process. So user sends a transaction to Scroll, and then sequencer collecting, ordering, executing via the executor. And then we have the rollup node that batches that transaction and posts data to Ethereum. And then we have the proving layer that now generates the zk SNAK proof. And then we have the verifier contract on Ethereum that now checks that proof. And if that proof is okay, then like Ethereum finalizes that batch, and Scroll's new state is updated. All right, it's as simple as that. User sends transactions, sequencer does its work, which is collecting, ordering, executing those transactions. We have the rollup node that now batches those transactions and posts data to Ethereum, the Elon. And then we have the proving layer that generates zkSNAK proof for correctness, verifier contract on Elon that checks the proof. And now if the proof is verified, Ethereum finalizes that batch, and Scroll's new state is updated. All right, so it's the same thing. Scroll's design being a VM equivalent, meaning like the execution layer on Ethereum alone, it's almost the same as that's in Scroll. And then proof-based verification, where now we're generating zk proofs for the batch of those transactions. Modular architecture. Now, modular meaning like we have different layers, every layer doing its job. Like not everything is done on one layer. Not Ethereum handling execution, proving, and verification all at once. We have different layers doing different things. Now, easing up the load on Elon, all right? And of course, open infrastructure built for decentralization and transparency. Okay. All right. Do we have any question up to this point? All right. We'll also be linking resources to the documentation and open to any question, of course. So yeah, that's like the general overview of how Scroll architecture is. If you understand that the settlement layer being L1, we have execution layer, the same one as that's on Ethereum, and the proof generation and the only proof being posted on Elon. I hope this was concrete enough. We'll be going through deep into details as we go ahead. So up to this point, we can try and look at bridging and how it means, and try also to deploy a simple smart contract on Ethereum. Again, yeah. So here we have like a simple smart contract. It's on my silly app on like feeding my cat. So we have a smart contract that rewards me some tokens every time I feed my cat. So this is the smart contract. We need to connect it. We need to have the Ethereum development environment. And the good thing about Scroll is that we don't need complicated development environment. If you know Ethereum's development environment, that's it. Yeah. So Scroll, and then we have hard hat and phone, either one, whichever feels comfortable to you. But Remix is sort of like easy to use for beginners, so that's what we will use. So just open Remix. Under contracts, of course, like creating a new contract. Yeah, so we'll name it the same as how have I named it? Token. Okay, hold on. Yeah, .sol, and then we just paste our contract. Make sure that it has no errors and we can compile it. All right. And under deploy and run transactions, of course, something else that need mentioning is connecting Scroll to your MetaMask. Okay, so we have the Scroll RPC URL for mainnet and testnet. It's the same as opening your MetaMask and adding a network. So you just come here, add a custom network, name it. Your name can be anything. For example, Scroll testnet, and URL. Of course, if you're using testnet, this will be the URL. Hold on, is it? Yeah, it is for testnet. Custom add. Already have it added, and then the chain ID being this one, and the symbol being Ethereum's, and you save. And then you'll have Scrolls testnet and network on MetaMask. And after adding that, either mainnet or MetaMask, you should be able to connect it with Remix. Yeah, so right here I have mainnet connected. I have a few tokens, and we can see now how we can deploy that. So connecting on environment, of course, go to browser extension, choose MetaMask, and you'll see the network right here and your address. Awesome. So after that, you can deploy your smart contract. Yeah, so in my case, I have like data showing the call data, but no worries, you can disable it also and confirm. So already been deployed. You can take the deployed contract, go to your application, have the logic here, and you can add. Okay, make sure it's running. Okay, I hope I've done this right. Connect to the wallet. Okay, I'm able to move this thing. Yeah, connect to the wallet. And if I do something like now feeding my card, let's see what data will show. It's calling this function from the contract. We can see it. Yeah, we can see the logic right there with the function. Go ahead and confirm. And there we go, you get our token. So we can also see the transaction on Scroll right here. I'll just paste the contract address. and we can see the transaction right there. And if you want to view the contract, it's right there. Awesome. So I hope it's clear up to that point. What do we mean when we say L1, L2 bridging? It's like L1 communicating to L2, Ethereum communicating to Scroll, moving assets from Ethereum to Scroll. And the best example is on this. For example, to be able to use Scroll mainnet, you need to bridge some Ethereum, and deposit it to Scroll. So make sure like you have some Ethereum, and then as simple as like putting the amount and then depositing to Ethereum. That means like you've moved some ERC tokens from L1 to Scroll L2. Yeah. Okay. Do we have any question? So on today's workshop, we've gone through Scroll's architecture and the simple process of deploying a smart contract on Scroll. Yeah. Any question, comment?
Hi, Nikhil. Thank you for the session. I'm just kind of curious about the people or the audience that we have right now, because we're going to be having more of these sessions. And yeah, so I don't know if you have time for people to just introduce themselves individually and tell us, what part resonated, which part is complex. Yeah, I think getting that feedback would be really nice, and also like a way to figure out what questions people really have.
Awesome. Sorry, someone just joined late. Need to know about the architecture. All right. And if you cannot speak, you can sort of like put in the comment, like, so about the architecture, we have the settlement layer, the sequencer layer, and the prover layer. Of course, the settlement is L1, Ethereum, sequencer on Scroll, and prover layer, also known as roller network, also on Scroll. Yeah, so settlement, different function, that's data availability, proof, verification, and bridging, and messaging. Sequencing layer, of course, it's receiving transactions from users, ordering them, executing them, and batching those transactions into like a batch or a block. Two components, execution node and the rollup node. Execution node being like a modified version of Go Ethereum. So like it's like a modified version of Ethereum's itself, Ethereum's execution environment itself. And now on this, like executing transactions, same EVM logic as Ethereum's, making Scroll bytecode equivalent to Ethereum. And we have a rollup node. After those transactions have been executed, we can patch them, coordinating with the prover layer to now generate the validity proofs of those patches, and submitting proofs to Ethereum's rollup contract. Yeah. So, and the prover layer, obviously handling now the cryptographic proof generation, and the type of proof that gets generated is the ZK snarks. We have ZK snarks and ZK stacks. So, ZK snark meaning succinct non-interactive argument of knowledge. Succinct meaning the proof is small. It's not as huge as ZK stacks. So, yeah. And that proof is posted to the first layer, settlement layer, that's Ethereum's. Now Ethereum verifies that proof, and if it's correct, of course, it finalizes that batch and now updating Scroll's state. So the process being user sending transactions, sequencer doing its work, collecting, ordering, and executing transactions. Rollup node batching those transactions and posting data to Ethereum. The prover layer generating the proof, and then that proof is posted on Elon for verification. If the verification is correct, Ethereum finalizes that patch and Scroll's new state is updated. All right. Is that clear? All right, so I'm seeing familiar names from the previous hackathon we had last week. So for someone like Crickson, I know you were able to deploy smart contract on Scroll. So maybe you can say if there's a confusing bit on Scroll, either on the zk side or something that you would want to know more on, yeah, when you hear Scroll.
Okay, so I think everything's okay. Yeah, so far everything's good.
Oh, awesome. All right, nice. Pfizer.
Hey,
Hello.
pardon?
Like we wanted this session to be interactive, so like if you have any question related to like the slides, deploying, or anything Scroll related.
No. Actually, I've understood. I was having issue with the bridging thing, but now I'm okay. Thank you.
Awesome. And were you able to do any bridging from Elon to Scroll?
Actually, I did, but now I'll try and do it.
Okay. All right, you just go here, and if you have some Ethereum, you can just deposit to Scroll, and that's it. Now you'll have now moved ERC tokens from Ethereum to L2, which is Scroll. Awesome. Kevin. Okay.
Hi,
Paul. Hello.
hi, good evening. Am I audible?
Yes, we can hear you.
Yes, I've been following on. I'm still catching up, but hopefully I'll be at par with the others soon.
Awesome.
Thank you.
Okay. Paul.
Hi, good evening.
Hello.
Can you hear me maybe?
Yes.
Okay, so from my end, I was just also just following, although it's late because as I have been waiting in the waiting room for a long time, so I just joined now. So maybe if you will mind sharing the recording of Norris.
Okay, awesome. Yeah, we will also be sharing the slides. Okay, so on zkEVM, basically EVM, Ethereum Virtual Machine. But now when we say zkEVM, see the EVM itself on Ethereum, but now we're producing zk proofs. Say upgraded EVM to produce cryptographic proofs. Okay, so zkEVM is just like approving those transactions, and we generate cryptographic proof. that's only getting posted to Ethereum. So EVM electrons execution would be happening on L1 itself, but now we have this EVM environment of mainnet, and the only thing that's getting posted to mainnet is the proof that's getting generated. Okay, I hope that's clearer, and I will be sharing the slides. All right, Dre.
Hey, yes, I joined when you were finishing up on the code. I think I'll just ask a very simple question, rather like just to clarify. zk came up a while ago, right? Or it's always been there?
Yeah, it has always been there, of course, like it, yeah, like the research has been there, but now we're seeing real development happening with zk. Yeah.
So so the zk part of Scroll, that being yeah, the zk part of Scroll built on top of the existing EVM is just to do the, I think I'm looking at the screen right now, do the post validity proofs on chain.
Okay, so the thing with Scroll, so it's built in a way that the execution environment on L1, it's almost the same as that one on Scroll. So the thing with Scroll is that now it executes this transaction of mainnet and it produces this cryptographic proof. So it only posts the proof to L1. Okay, so Scroll is an L2, and the work of L2s or rollups is to offload L1. So Scroll produces the cryptographic proof that gets posted to L1. So yes. Okay, is that
Okay.
clear?
Yeah, I think it's simple. I think like it's clear to me now that what Scroll plays a part in, and I'm guessing that's one selling points. Like, why would you choose Scroll? Is that you get your proofs on chain. I'm guessing this is how even because I was checking out the USX Neo Dollar, how they're able to do it privately. They're making use of this, right? Okay, cool.
Which one is that?
USX,
No.
or
Awesome. Well, I will take a look at that. But yeah, it's you said like producing the zk proof on chain. So it's only posting the proof on chain, but every other execution is off chain to the rollup. Okay.
oh, yeah, sure.
Awesome.
Okay.
I hope that's clear. Joanne, any question or comment? Or we good? Awesome. So we'll be continuing with these workshops weekly, getting more into what Scroll is and the zk aspect of it. So yeah, thank you everyone for joining today's session. Yep. Any comments, Matu, Roslyn? Yes, of course. We'll share the slides on Telegram and WhatsApp.
Hi. Yeah. So actually, before we leave, I just wanted to talk to you guys about the content hackathon. So guys, if you have seen the instructions, don't shy away from like signing up and participating in the challenge. So if the video is, you can do both challenges, like the thread form or the video form, or you can do one challenge. But the more the challenges, the more the points for you. So if it's a good chance for you to learn about the projects that were incubated at Open Economy. So yeah, if you have any questions, just DM me and I'll be happy to answer. Thank you so much. Thank you. Thanks, guys. Good night.
All right. Bye-bye.
Bye. Bye, guys.